Hey everyone, this is from Team Spaceonova. This is our YouTube live, and today's topic is space robotics. And amongst us, we have a very eminent personality in the field of space sciences, Miss Shreya Santra. She's currently pursuing her PhD in Space Robotics Lab in Tohoku University, Japan. And she is a Japanese government MEST scholar as well. She's also a visiting PhD researcher at German Aerospace Center. And we're so glad to have you on board, ma'am. And we're so thrilled to gain knowledge from you. Over to you, ma'am.
Hello, Nayantara. Thank you so much for the introduction. And I'm really glad that you invited me to give this talk on space robotics, a topic that I'm so interested in. So I'll share my screen to start the talk. Uh,
Yes, ma'am.
okay, just let me know. Just a minute. Okay, can you see my screen?
Yes, ma'am.
Should it be visible?
We can see it.
Cool. Okay,
Yeah.
okay. So, as Nayantara said, I'm Shreya Santra, a PhD student in space robotics at Tohoku University in Japan. And currently, I'm doing my PhD in as a visiting researcher at the German Aerospace and in Munich. So, the talk of today's, the plan of today's talk is as follows. I'll give a brief self introduction and then dive straight into the topic of what is a robot, what are the different applications of robotics, and how robots can be used in space exploration. And then move on to the challenges in the space robotics research and the future of space robotics. And also, if you are interested, how to plan a future in this field. So it might get a bit technical in the middle, but just stay with me. And it is mostly an overview of very interesting topics. And I hope you all can take away some vital information from this session. So a brief introduction about me. I grew up in the coal capital of Dhanbad in Jharkhand, and I was always intrigued by the night sky and the science subjects. So I always used to read a lot of books in libraries and a lot of encyclopedia and Britannica, etc., and look at like all the beautiful pictures of cosmos and all that. So I was always interested in it. But then I started taking it more seriously when I saw the Columbia disaster in 2003 on TV, and I saw the space shuttle Columbia, in which Dr. Kalpana Chawla was on board, shattering in front of my eyes on the TV screen, and I was so shocked. And that's what like shook me, and I started taking this field more seriously. And I read a lot of books about Kalpana Chawla and how she grew from such humble backgrounds. And I read a lot of books by Dr. APJ Abdul Kalam, and those were very inspiring for me. And so, like after my board exams, I went on to enroll in BTech in Electrical and Electronics Engineering at NIT Jamshedpur. And like during my 4 years of my undergraduation, I did a lot of online courses on satellite engineering and stuff because I was always interested in the space sector. And in my third year, I got an internship at Indian Institute of Astrophysics in Bengaluru, and there I met a lot of people who were working on space sciences and got to know about this field more in details. And I also got to know about the International Space Studies in France. And it was a very interesting university. I learned more about it and then applied for it. And then 1 year I spent in France, and I worked on many projects related to space and aerospace. I learned a lot about the space sector and all the different careers that we can make in this sector. And I also got to do some internships in Netherlands and Luxembourg. And after this, I went on to Moscow and Skolkovo Institute of Science and Technology to study space and robotic systems. And here I worked on stratospheric balloons and on the small satellites and on robotics. And all these years, I got a lot of time and a lot of opportunities to work with international and interdisciplinary people from different parts of the world. So it was a very enriching experience. And since 2018, I'm doing my PhD in space robotics at the Hoku University in Japan. And currently, as I said, I'm in DLR at German Aerospace Center in Munich. So as you can already figure out, I really like to explore the world and the universe, and I've been all over the map, and I've also been to NASA, JPL, and like really thankful to my research and all the scholarships. So I have got that I got to travel a lot. So moving on, as I said, I'm in the Space Robotics Lab, which is directed by Professor Kazuo Yoshida, and he's well known both in the space and robotics sector. And he was the chief technologist of the Hakuto team, which was part of the Google Lunar X Prize. Maybe some of you already know about it. I'll tell more about it later. And so in our lab, we conduct studies on locomotion, navigation, and control strategies of various types of robots for applications in space environment. And we also collaborate with the German Aerospace Center, with NASA and the Japanese Aerospace Agency. So, what is a robot? Well, the robot term was coined by Karel Čapek, a Czech writer, and in Czech language, robota means forced labor. Uh, According to the Wikipedia definition, a robot is a machine, especially one that is programmable by a computer and is capable of carrying out complex series of actions, either automatically or guided by an external control device. So as you can see, like a robot can perform repetitive tasks that can assist the workload of human and also carry out uh, like tasks which humans are unable to do because of size limitations or unsafe environments. So there are various applications of robotics, like in industries and services and entertainment and nuclear power plants, which are very, uh, very dangerous for humans to operate, and also disaster and war sites on the bottom of the oceans and outer space, of course. So robots can be of different shapes and sizes depending on their applications. For example, they can be like human type robots, or they can be animal inspired, bio inspired robots. And also, there are assistive and collaborative robots which can help, like as an exoskeleton or for surgical or medical purposes. So, coming to space, we are a curious species. We all know, like, humans are a curious species, and we want to explore the earth, we want to explore the universe for various reasons, right? And there are some of the reasons are to, like, understand the origin of universe and our planet, to know if we are alone in this universe, and to have a habitable backup of our earth. So we want to explore space, but space is one of the most like, as we cross the atmosphere of earth, space becomes like the one of the extreme environments that can be imagined. So there are many advantages of robots to be used in space exploration, such as I said, space is hostile. There is conditions like radiation, extreme temperatures, microgravity, micrometeorites, and also orbital debris floating around. So it can be very dangerous for humans to work in space. Then there are like difficult tasks like construction of habitats or on-orbit servicing, which are kind of infeasible and difficult for astronauts to do those, because astronauts have to wear all the protection gears and wear gloves and everything. So that kind of limits the dexterity and capabilities of astronauts. And of course, because having robots in space are more cost effective and low on risk. So uh, it's better to have robots over uh, risking human life. So these like robots, when they are robustly built and programmed and trained, they can perform a lot of different tasks in space, such as exploration, and surveying, assembly and construction, also maintenance, servicing, and also robotic landings can be performed. So, depending on the different tasks, the robots are divided into two general working areas. One is the orbital robotics, and other is the planetary robotics. So for orbital robotics, these are designed mostly for orbital operations and services, for space debris removal, and also for microgravity research in the orbit. Then there are planetary robotics, and these are basically probes for scientific exploration, and these are the precursor of future human expedition to like remote worlds. So let me introduce you to the first space robots that were ever sent from Earth. In the 1960s and 70s, the USSR, which was the Soviets, they launched a number of landers and rovers to Venus, to Mars, and to Moon. And these rovers and um, landers, these became quite like, some of them were successful, some were not successful. As you can see here, Luna Code 1, this was one of the first rovers that traveled on a remote world, on another celestial body. And following that, NASA also like launched a few Mars landers like Viking 1, Viking 2, and of course, we know the Apollo program, in which NASA sent the lunar module and the moon buggy, which was basically a car that was driven by the astronauts around on the surface. But all of these systems were very rudimentary with no intelligence and needed to be controlled by humans. And then we come to the first orbital robot, which was the German Aerospace Center's ROTEX mission. ROTEX is basically Robot Technology Experiment, which was sent on STS Space Shuttle 55 as a Space Lab D2 mission. And it was kind of like a precursor mission for on-orbiting servicing, and had advanced features like sophisticated multi-sensor gripper technologies and local intelligence and feedback capabilities. And it performed a number of tasks as part of the experiment, like assembling, grasping, and both autonomously as well as teleoperated by scientists on Earth. And since then, there have been a number of missions for satellite capture and servicing demonstrations by the Japanese Aerospace Agency, and also by NASA and DARPA. So, coming to the most recent space missions, we know like Mars is one of the most exciting planets to land and to operate robots. It has a rocky terrain, and it has no plate tectonics, low gravity, and no magnetic field. And it has been like visited by a number of landers and rovers, like the Phoenix lander, the Pathfinder, the Spirit, and Opportunity rovers. And it is like Mars is supposed to be as like a twin planet for Earth, and it might have supported life earlier, or it may support life in the future. So it's a very interesting planet to explore. And the most recent ones are the Curiosity rover and the Insight lander, which are currently working on the surface of Mars. And these have mechanisms to collect samples and to analyze the samples. So, following that, we have the China's Chang'e mission U-2 rover that went to the far side of the moon, and it has been exploring that part of the moon and sending very interesting pictures. Also, there is the Canada arm, which is on board the International Space Station to help the astronauts to capture different modules and resupply missions. Then maybe very recently, you heard the news of the spacecraft OSIRIS-REx from NASA that touched the asteroid Bennu and collected a lot of samples. So asteroids and comets are supposed to be like the carriers of life and may have brought water on Earth. So these are very interesting celestial bodies to explore. So there have been many missions by NASA and the Japanese aerospace to send spacecrafts to asteroids. So, like the Japanese aerospace agency dropped two small tumbling and hopping robots on the asteroid Ryugu a couple of years ago as a part of technology demonstration. Also, the European Space Agency, they tried to the lander called Philae on the comet 67P Churyumov-Gerasimenko. Although it did not land at the desired spot because the harpoons fired at the wrong moment, but then it ended up in a shadowed region, and because the lander is like powered by solar panels, it is not able to get the sunlight, and now it's like under the shadow. But anyways, it was a very good mission to show how to land and some novel technologies in there. In 2005, the European Space Agency sent a probe called Huygens on board the Cassini spacecraft, and this probe descended into the atmosphere of Saturn's moon Titan, and it revealed an interesting ecosystem that it might support life on Titan, because it has a very like dense atmosphere and maybe subsurface oceans. So also there are some small robots floating abroad the International Space Station, also called Astro B robots, and these robots are like used by scientists on Earth to conduct experiments with the help of astronauts. So we went through what are the recent robotic missions that are going on. Now we'll look through like the main planned missions for the for the upcoming decade. The most recent one is the Perseverance rover by NASA along with the Ingenuity helicopter, which was launched a few months ago and will arrive on Mars in February of 2021. And this is a very advanced rover with very advanced, sophisticated instruments to search for traces of past microbial life, as well as it has a technology demonstration to fly a helicopter, which will be like the first ever on a different planet. Then there's the planned Chandrayaan 3 by the Indian Space Research Organization, and they will attempt a soft landing of a lander and then drive a rover. We know in Chandrayaan 2 it did not happen, but of course we all learned from our failures and mistakes, and I'm hopeful that this will be a very successful mission. Then the ExoMars 2020, which is by the European Space Agency. And this is a rover that will drill deep down into the Martian surface, 2 meter deep, which is really quite deep, and it will analyze the samples with some next generation instruments on board the rover. Coming on to like planetary robotic orbital robotics, so Restore L mission is proposed by NASA and Maxar Technologies, which will do on-orbit servicing and like refueling, repairing, and relocating another satellite. One of the very interesting missions is the Martian Moon Exploration, which is a Japanese uh, mission. And on board that spacecraft, there will be a rover, which is a French German rover, and it is being developed here in the German Aerospace Center. And I suggest, like you, after this session, maybe go to the DLR website and look for this video, because it's a very interesting rover or a robot, because it can rove, it can also walk, and it can also tumble. So it's a very interesting one. Then there is Europa Clipper by NASA, because we know from observations by the Hubble Space Telescope that Europa, which is the Jupiter's moon, might have subsurface ocean and might be like have water jets rushing out. So there is a robotic spacecraft that is being developed to fly to this moon and capture the samples from these fountains or plumes. And another one is Dragonfly, also by NASA, which would be later of 2020s. And this will go to Saturn's moon Titan. As I said, like Titan has a very dense atmosphere and low gravity, so we can use like this for the advantage of our of like take the principles of aerodynamics and then fly a UAV. And this is a octocopter or a dual quadcopter, and it will investigate like organic chemistry and biosignatures in Titan. So we look through the robotic missions, but there are multiple challenges that are to be solved for future robotic space missions. Some of these are like protection from harsh space environment, mobility technologies in different terrains. Power limitations is a big factor, because if the robots are going into deep space, then they are not able to be powered by sun for long durations. Low mass requirement, it is important that we have like smaller robots, or at least like of acceptable size robots to be launched. Reliability is important, because we don't want our robot to go to space and like not work anymore, because it's just a waste of time and effort and everything and money. Remote operation, so once the robot go into space, there is communication delay, and it's really important, like really difficult to operate these robots from such long distances. Autonomous capabilities are a challenge, because the robots are still not so intelligent and not autonomous, and uh, need to be controlled. And testing, which is important to have like test these robots before they are sent to space, so as to ensure that they work as desired. So there are like core robotic technologies, which I'll be briefly going through in the modern space robotics. So the first one is robot mobility and locomotion. And to maximize the performance and power efficiency of the robots, it is important to understand the traction mechanics. So a number of designs of wheeled rovers are being researched on based on the different soil properties and different terrain of the celestial bodies, and also like different materials for the tires, which will enable the rovers to go farther and faster. Because currently these rovers move at a very low speed. Then so this is for like mostly flat terrain, but if the terrain is steep or uneven and has hills and caves, then wheels will not work, and then we have to come like consider limbed robots or walking robots, which can climb hills and mountains. So here you can see the NASA Lemur robot as for like being tested in Utah Desert. Again, like if there are minor bodies like the asteroid and the comets, which have very low gravity and very low escape velocity, then it is difficult to control wheel and walking robots. And so we have to use tumbling or bouncing kind of robots, and by oscillating the weight and the changing the torque magnitude of these robots, it is possible to control the speed and the direction of these robots. So next is, like as I said, if the atmosphere is dense and there is low gravity, then we can use flying robots. Here is like the Ingenuity helicopter, and also the Dragonfly, which will fly next year to Titan. So we can use these kind of UAVs to explore large areas. Next, if so, for example, Europa and Enceladus and some other moons in our solar system has subsurface oceans, and it is not impossible to have like proper wheeled robots to move around on these icy on these oceans. So NASA scientists have come up with floating or buoyant robots. Here you can see like the Brui from NASA, which can operate under the beds, under the ice beds in the water, and explore these waters and see if these liquid have any kind of biosignatures or can support life. And again, if you see like pictures of Enceladus, these they have plumes of water gushing out from the south pole of the moon, and these are like narrow fissures or narrow crevices which are hard to get into. So we can look into snake-like or eel-like mobility so that we can get into these narrow crevices and explore the unknowns which are there inside these crevices. So these are just a few examples, and there are many more innovative locomotion technologies that are coming up to explore different types of space celestial bodies. Next technology is the robot autonomy and intelligence. So how do we make robots intelligent? It is simple. We make them more human-like. So we equip them with a brain and a nervous system so that they can sense, think, and act. So robots can have components like controllers, actuators, sensors, etc. And the sensors can collect information, and the controller can process the information, and then the actuator can execute the actions. And and so basically, like giving them all of these properties and all of these capabilities so that they become more intelligent. And the recent advances in computing has allowed the robots to learn from their experiences. And these sensors can collect data, and then they can store the data, and train the systems to learn and respond. It is just like a newborn who, it's like mimicking a newborn who observes the environment and then experiences and then remembers the experience and responds in future responds to similar situations in it by thinking. So we want the space robots to operate independently and to make decisions when they like encounter unknown environments without human intervention. So we aim to have like at least 50% of human scale autonomy, and some of the characteristics like to prevent an accident or at least recover from accidents, and to learn and adapt to the different circumstances, and also adjustable autonomy so that they don't take decisions all the time but maybe have some human to control them as well. Next technology is sample collection and analysis. So uh, why are we developing the robots? We want them to go and explore and collect samples and bring back so that we get to know more about these celestial bodies or about microgravity. So there are different data collection techniques. So one of those is the optical instruments, which take images in different electromagnetic spectrum. Also here you can see sorry. So here you can see the sample collection technique that was developed for Hayabusa 1 in our lab. And Hayabusa 1 went to the asteroid Itokawa and then collected samples and brought back to Earth. So this is one technique for sample collection. Then there is a drilling mechanism that the InSight lander and maybe the Perseverance rover will be using to drill into the surface of Mars. Then there is the scooping mechanism, which is used by InSight lander to scoop and collect the data and then analyze them. And as I said, like different instruments to analyze the soil and analyze the different samples. So these are like different kind of sample collection and analysis. Of course, there are more, but these are just an example. So, okay, we have built this robot and everything, but before we send them to space, we need to test them. And we know that they are very crucial systems, and we, of course, don't want them to malfunction once they are in space. And so we need to test them and know that they are performing as desired in space. But it is very difficult to test space robots because, of course, we are on Earth and all the conditions on Earth are very different from those on space. So we try to like simulate space through different softwares or different model-based experiments and simulation for robots, and also like physical tests. Like here you can see sandbox experiments, which is nothing but a box of sand with that are filled with sand or soil of different textures and different compactness, and you can change the angle of this sandbox so that you can test the slippage and the how the wheel and the soil particles are interacting with each other. Another one is air bearing tables. Here you can see in this video there's a table and then there are like cables that pushes air out of the table, and this gives impression that the spacecraft is in microgravity. So they move around like a free floating object, and it is used to test orbital robotics. So you can see here they're just moving around like a free floating body. Next is like climbing walls, which are for walking robots, to gate planning of walking and climbing robots. Here, as you see, like it's climbing up a wall just like a human would climb up a rock climbing uh, sessions. And other than this, NASA and European Space Agency also has Mars yards to test their robots. And inside, like they have these kind of grounds with rocks and steep slopes and everything. So they use these areas to test their robots. So these were like the indoor facilities in labs. But before we send them to space, we need more robustness. So we need to test more, and it is necessary to test them at analog sites. Analog sites are nothing but the places that are on Earth, but resemble those on Mars or Moon or Enceladus and other planets. So some of the analog sites I have listed here are like Ladakh in India. Then there is Antarctica, where you can see NASA is testing their robot. Then there's Mount Etna in Sicily, which is a volcano. Also, Hawaiian Islands are some places where you can test. And then there is Utah Desert or Death Valley Desert in USA, where they also test these robots just to see how they are performing in these kind of terrains. So yeah, that was for like how space robots in general are developed and tested. Coming to my research is like on swarm robotics, and I'm working on communication and navigation strategies of multi-robots for planetary exploration. And multi-robot exploration is now a very hot topic, and many research institutions are studying it because it has many advantages, like it increases the redundancy. So of course you have, if you have multiple robots working in an area, and if one of the robot breaks down, you still have many other robots, and you can explore larger areas and have higher scientific and commercial values. And also they can be more flexible and cost effective. So yeah, like, and my team of space robotics that I belong to, we are involved in developing algorithms for simultaneous localization and mapping, and for autonomous driving, for decentralized path planning, and also robotic intelligence, swarm intelligence via artificial intelligence and reinforcement learning. So So that was all for most of the technical part. And for those who are interested in space robotics, there is a lot of scope in this field. As you can see, like the space robotics market will continue to grow with a compound annual growth rate of 10.2%, and it will reach over 3.5 billion US dollars by 2025, and it has a lot of potential, especially in Asia and North American region. And so there is a lot of opportunity that this, as this industry will keep on flourishing and expanding. And actually, interestingly, during this pandemic, we realized that not all work can be or should be done by humans. So that's where robots come into rescue, and space is one such place where robots are very important. So and we keep saying like we want to make space more accessible, and there is this new space now happening with a lot of commercial players getting into space business. So I believe like robotics is gradually becoming part of the new space ecosystem, as public and private partnerships are becoming like the forefront of space exploration. So it is expected that the commercial segment of the robotics, space robotics, will become very dominant. in this decade and the next decade as well. And some of the examples are like the Google Lunar X Prize challenge, which ended in 2018. It did not have any winner, but it gave a spin-off to produce many different spin-off companies, such as like the Robotic Technologies, which now has deals with NASA to provide payload services to the moon, and they have also developed the Cube rover, which is a small rover that will go to moon, being developed by students and yeah, by students. So next is iSpace, which is a Japanese company, which was the spin-off of the Hakuto team, and they are building landers and micro rovers to be launched to the moon in the next few years, next couple of years. Space IL is a Israeli company also that participated in the Google Lunar X Prize, and they attempted a landing in 2019 on the moon. Fully Space Technologies, they are building like innovative rovers for lunar exploration. Then there are these companies like Honeybee Robotics, Motive Space Systems, Asteroid Mining Corporation, who are also involved in building robots for debris removal, for satellite on-orbit servicing, and for asteroid mining. So hopefully we will also see similar new space robotic activities in India as well in the next few years. So if you want to like get into this field, there are many trends that are catching up, like swarm and multi-agent exploration, modular robotics, bio-inspired mobility, also self-repairing robots, shape-changing or origami kind of robots, so that you can so that the robots can change their shapes depending on the region that they have to explore. Human robotic interaction, very important topic, because we want more human and robotic collaboration in space, because robots cannot do everything and humans cannot do everything by themselves, so they have to collaborate. Then there's machine learning and artificial intelligence, always there, and in situ manufacturing and services. So there's still a long way to go for space robotics. There's a lot of gaps that has to be filled up, but of course scientific research never stops, and we should always aim to widen our space horizon. So if you are planning a path in space robotics, these are some of the skills that I think we should have, like develop logical and critical thinking, judgment, and decision making, basically like having the same skills that we want our robots to have. So we should learn these first, and then we can program our robots to have these. Any programming languages are always useful. Python and MATLAB, these are some very common and very useful like the programming languages. And if you want to pursue robotics either in abroad, you can look for scholarships and appear for exams. This is a link. You can go to this link and you will find a list of all the universities that provide courses on these on robotics and space systems. This is a link. I have like a sheet that I have prepared, a list of all the universities. So definitely check this out if you are interested. And most importantly, be patient and persevere, and always be passionate about what you want to work into. And it doesn't matter even if you take different approaches. Always be passionate about what you want to achieve and keep working hard. And lastly, I would like to say, like, always stay updated. You can join the different organizations and build networks, and subscribe to newsletters, so that you are always updated of what's happening in the space field, what's happening in the uh, in the space robotics field, and all these. And these are some of the organizations that I think can be very useful if you want to be involved in this field. And with that, I end my talk. And you can always reach out to me for those who are watching through ResearchGate or LinkedIn. And yeah, thank you for your time and thank you for your patience. And now I'm open to questions.
Thank you so much, ma'am. That was a brilliant presentation, and I'm sure we all got a different new perspective with regard to the field of space robotics and technology that space robotics is to implement in future. So I'm sure we all had insightful information and very useful stuff that we learned, especially stuff like swarm intelligence and things like that. So, ma'am, I just have a question. You mentioned swarm intelligence and swarm exploration. Can you explain that in layman's language?
Okay, so swarm is basically like having like a swarm of bees or a swarm of ants, where the different insects or the different agents, they work together to achieve a common goal. Okay, so that's what we want our robots to do as well. They can be of different capabilities, but they work together and they are intelligent enough. So, swarm intelligence, so they are intelligent enough to communicate and coordinate between each other so that they can explore the area that we want them to.
Right, ma'am. And we also had great insights on space robotics markets, which I don't think a lot of us have really thought about. And I'm sure this has given us a chance to research on such a topic, and where there's so much of money being put into it. And by 2025, it's going to be a $3.5 billion sector. So I'm sure we've all had a lot of insights from all of these that you've mentioned, and the new space robotics, including the Google Lunar X Prize and all of that, that we have a chance to participate and gain more knowledge, and and the scholarships that you mentioned. And you've really given us extremely useful insights on all of these. So, ma'am, moving on to a few questions that we have. So you mentioned about rotex. So how has space exploration and space technology evolved since the time of rotex?
Okay, so Rotex was the first on-orbit space experiment back in 1993, and it was like a demonstration where scientists here at German Aerospace, they tried to control this robot up there, and so they tried to do different kind of demonstrations like grasping and assembling, etc. So since then, there have been a lot of advancement, especially in the computing and also in power and low mass. So robots have become more efficient and smaller and more intelligent since then. And now, like we have the Canada arm on board the International Space Stations, and also different small robots inside the space station if we talk about orbital robotics. And as you see, like there are some demonstration on kind of repairing and refueling different satellites. Especially Japan has like showed many missions that can be used for servicing, on orbit servicing. Other than that, so in this in this case, in Rotex and other robots that I was talking about, these are robots that were uh, up in space, and the scientists tried to control them from here on Earth. But then there have also been demonstrations where uh, robots here on Earth in NASA or German Aerospace, they are here on in the labs, and astronauts on board the International Space Station, they try to control these robots. So it's basically a teleoperation, just like how we can do when we are having, like, when we are building a base station on the moon or on the Mars, we can have astronauts on orbit to control the robots. So these are like some of the evolution that has happened since then.
Right, ma'am. And also, NASA's legendary Mars exploration rover mission involved two rovers, as you rightly mentioned, Spirit and Opportunity. So, what was the reason behind the success of these two rovers in terms of technology and design?
Okay, so I think basically success is mostly because of the tests. NASA does a lot of tests before they put on their rovers up there. And it's very important to test in different circumstances, as I said, like in lab as well as outdoors, in and also, like, there are different other testing facilities such as the anechoic chamber, the thermal vacuum chamber, and all those things where you test these systems on, so that they can withstand the harsh environment on Mars. So I think test is very important, and as you said, like, it was only planned for 90 days, but they continued to work for so many years. Same as for Curiosity rover. It was planned only for 2 years, and now they are like, now it's already 8 years since they are on, since Curiosity is on Mars, and it's still operating. So robots in general are very robust, and that's an advantage that we have to use robots in space.
Right, right. So, coming back to the Indian Space Research Organization, so ISRO wants to send a legless humanoid robot named Vyomitra. So, what are the unique features of this robot, and how is it planned to be used in future missions of ISRO?
Okay, so like, I have a backup slide on Vyomitra. Yeah, so Vyomitra is a legless humanoid robot that is proposed by ISRO, and it is the principal, so ISRO, which I think is right in aiming to not send animals into space. We don't need to send animals without their consent into space. So they are building robots to study the effects of microgravity and space radiation on humans for long duration missions. So I think it's a very good idea. And this robot, Vyomitra, it is like, it can mimic humans, it can answer to queries, it has artificial intelligence, and it can, like, assist as well. So it's supposed to go in the first uncrewed mission of Gaganyaan, and maybe later as well for the crewed missions to assist the astronauts. So I think that's the aim, and it's a very good idea to send robots first instead of humans.
Right. So, ma'am, do you think humanoid robots will take over human beings in the near pursuit of space exploration?
No, I don't think so, because we see on Earth, like, of course, we already have advanced technology on Earth, but they haven't taken over us. And I don't think they will take over humans anytime, because humans are capable of a lot of things, and humans are the ones who are like computing and programming these robots. So I don't think they will take over. But as I said, like, as we move forward, as we continue exploring, it's very important to have human robotic interaction, and it's a very important topic of research. So there are, like, different ways in which you can interact with robots and control them. Here you can see, like, the glove, which uses haptics feedback to control the robot, and basically the robot can feel just like we feel when we touch something. So that's one kind of way we can interact with robots. And also, this might be very science fiction, but also I think it's possible later to control humans with our control robots with human intuition. So what we think, we can kind of control the robots by our thoughts. So yeah, like we can do telepresence and teleoperation, uh, and we need the robots, and the robots need us.
Yeah, right. So it's a two-way thing, and
Hmm.
we hope it continues that way. Um, Also, ma'am, you mentioned about Cube Rovers, which is a project done by students. So, can you give us more insights on that?
Yeah, so Cube Rover is being built by Robotic Technologies, and this is in collaboration with Carnegie Mellon University, and they are collaborating with the students to build these kind of small rovers. So, as you know, CubeSats are very
Right,
common now
right,
with students, and we can build CubeSats and smaller satellites so that we can go to go to space and do some simple experiments or observations. So similarly, we want like it's important that we have robotics also accessible to the to us, to students, and to commercial partners. So that is what they are trying to do. They are trying to establish a standard for cube rovers, and it's already a company now. It's a branch of Robotic Technologies, Cube Rover, which is based in Luxembourg, and they are building like small micro rovers.
right, ma'am. Right. So, you also mentioned of rovers that are being used to investigate asteroids. So, are they the same things as rovers sent to planets, or do they have a completely different technology that assists them?
So as I said, like back there. Okay. Yeah. So hmm, okay. So robots for minor bodies or microgravity environment. So these are a bit different from planetary robotics. So these are because these minor bodies, asteroids or comets, they have very low gravity, very less escape velocity. So we need to be very careful when we design systems like this. And if you see here, uh, so if you see this video here, the satellite or the spacecraft touches the surface and bounces back because the escape velocity is very less, so you cannot really walk or uh, use wheels
Yeah,
to move on the
yeah,
surface. So that's why they use like technologies like bouncing or tumbling, which I showed earlier.
yeah.
So yeah, that's one technology. And there are like technologies being developed for asteroid mining, which would be like capturing the asteroid and maybe trying to extract the minerals from the surface.
Right, right, ma'am. So we have a few questions from our viewers, ma'am. So, firstly, we have a question, which is it possible to use polymer solar cells as sources of energy for the functioning of space robots?
I think it is possible to use solar cells made of polymers if the efficiency is high, but we have to know that the solar energy does not work beyond say Jupiter, beyond Mars, or beyond the asteroid belt. So so we have to move on to different other energy sources like nuclear RTGs. Maybe also use like the magnetic field of Jupiter to propel and to use that energy for powering the spacecrafts. So I think the solar cells can be useful, but it's not a long-term deep
Yeah.
space exploration. As we
Yeah.
can see, as I said, like the lander Philae on the comet, it landed up in a shadow under a big rock, and now it's basically not functional, and yeah, it's not worth it to have just solar cells. And we can like we and if we see the Voyager 1 and Voyager 2 missions, they used RTGs, the nuclear RTGs, and they are now out of the solar system and they are still transmitting data, and that's like one successful mission. So we have to be like that.
Yeah. Right, ma'am. Another question that we have from Anubhansu Runsu is what languages are used to code them? I think them refers to rovers.
Hmm. Yeah, so as I said, uh, well, languages keep on evolving. Computer languages keep on evolving. There are we started with Photon and like very basic languages and C++, and currently it's Python. And Python is a very user-friendly language, and it's one important language to learn. But anyways, it's the logic that is important. We should develop the logic thinking, and then we can program in any language. It's just the syntax that matters. So right now they are like my robots. They are coded by Python and C++, and I use a lot of MATLAB as well, and for the simulation and coding.
Right. We have another question from Srinivas Khatri. He says, I'm a science teacher. How can I guide my students in this field?
Okay, so if it's a school teacher, then I think it's always nice to show students how vast the space is, and still how we can still accessible to us through different technologies and different robots and spacecrafts and etc. So like show them images, show them nice videos. Like now there's so much information on the internet, so I guess like showing, also introduce them to nice books on space and cosmos, and maybe I think one of the most inspiring is Carl Sagan's Cosmos series. So watching Cosmos series can be very inspiring and very motivating. So maybe these are some things you can guide the students. They are in school, so yeah, you don't really have to tell them a lot about the technology, but basic things, and also maybe some programming, some designing, hands-on designing, some electronics. Yeah.
Yeah. And there are so many simulation tools available online. So I don't think it's very difficult to get students to do the coding and simulation. Right.
Mhm.
Um, Another question that we have from Siddhant Sarkar is, could you share your LinkedIn and ResearchGate profile URLs?
Okay, I think, okay, I'll share the link with Spaceonova with you, Nayantara, and maybe you can
Sure, ma'am.
put it in the description of the
Yep,
video.
we'll do that.
Yeah, okay.
Our next question is from Vijay Kumar. Considering moon's atmosphere, is it possible to fly drones on the moon?
I don't think so. It's possible to fly drones on the moon. There have been some attempts, but if you see like some videos of Apollo mission where the astronauts are like jumping when they are moving, so it's really difficult to even move, and it's just like the minor bodies has very low gravity and no atmosphere. So yeah, I don't think it's possible to have the aerodynamics and lifting and drag. if there's no atmosphere.
Right. So I hope that has answered all our viewers' questions and they're satisfied. Thank you so much, ma'am. We had such a it's such a pleasure to have you on board and have your insights. We were thoroughly enthralled with all the valuable information that you provided us with. So the link to ma'am's LinkedIn and ResearchGate profiles will be shared in the description of the YouTube video. And those who need it can have a look at that. Thank you so much, everyone, for joining in. And we're super glad to have had all of you. And we hope to see you all for the upcoming live sessions as well. Subscribe to our YouTube channel so that you don't miss out on updates on future webinars that we'll be conducting. Also, follow our Space Nova's Twitter, Facebook, LinkedIn, and Instagram accounts to stay posted. Thank you all, and we'll see you soon. Thank you so much, ma'am.
Thank you so much for having me. I
Thank
really
you,
enjoyed
ma'am.
it.
It was a great pleasure. Thank you so much.
Thank you.